Hello friends, welcome to a fresh new episode of our channel RG Innovations. If you have not subscribed already, please subscribe to our channel, click on the bell button and select all to get all future notifications of our video uploads. Today we will be working with EEPROMs, a type of memory chip that retains its data even after your project is turned off or powered off. Oftentimes it happens that we need to store some data into an Arduino other than the program code or sketch to use after the Arduino is run next time. For this purpose, there is an EEPROM other than the flash memory which stores the sketch. Now we are going to learn more about EEPROM. Computers and microcontrollers need memory for data storage, either temporarily or permanently. Memory comes in various forms but generally falls into two broad categories, volatile and non-volatile. Volatile memory is usually in the form of RAM or random access memory, which is the working memory for your device. It stores temporary data used during program execution. Once the power is removed, this memory is erased. And non-volatile memory, as the name implies, retains data even after when the power is off. There are several kinds of non-volatile memory, and today we will focus on one of them, electrically erasable programmable read-only memory or EEPROM. We will discuss how to use EEPROM with an Arduino. There are many other types of non-volatile memory such as flash memory, SD cards, USB drives, hard disk drives and SSDs. So where does EEPROM fit into this? Compared to other non-volatile memory types, EEPROM has much smaller storage capacity. Because of its small storage capacity, EEPROMs consume less power, making them ideal for low power or battery operated applications. EEPROMs are similar to flash memory, but there are some significant differences. Flash memory has larger capacity and uses bigger data blocks. This leads to a reduction in the number of rewrites or write cycles. Arduino microcontrollers use flash memory to store uploaded programs known as sketches. And Arduino also has some internal EEPROM which we will explore later in this video. Other types of ROM include the following. ROM, that is read-only memory. These chips are programmed during manufacturing and cannot be altered. PROM, programmable read-only memory. These chips can be programmed with a special device but they cannot be erased or reprogrammed. EEPROM, erasable programmable read-only memory. Like PROM, EEPROM requires a special programming device. However, this type of memory chip can be erased using ultraviolet light and can be reused. We have here shown in a chart different types of ROMs. But since we are going to discuss about EEPROM, we are not going into much detail about this type of ROMs. EEPROMs are easier to use because they don't require a special programming device, unlike other ROM types. However, EEPROMs also have a limited number of write cycles. You can read from them as much as you like it, but there is a limit to how often you can write or rewrite data. For typical EEPROMs, this limit ranges from about 100,000 to 2 million write cycles. Although this may seem like a lot, modern microcontrollers can write data very quickly, making it a potential limitation. If you were to rewrite to the EEPROM every second with a capacity of 100,000 write cycles, you would exceed the limit in a little over 1 day. When designing with EEPROMs, you should minimize writes. One technique to reduce unnecessary rewrites is to read a bit before writing to it. No need to rewrite if the data is already correct. Another limitation of EEPROM is its data retention time. Although EEPROM technology is improving, current EEPROM can hold data for about 10 years at room temperature before the data may become corrupted. Rewriting the data resets the counter, prolonging the EEPROM's life. Finally, EEPROM storage capacity is limited compared to other memory devices. However, since EEPROMs are often used to retain configuration and calibration data, this isn't typically an issue. So what is the application of an EEPROM? We will see the applications in Arduino projects to remember the last state. The EEPROM is useful in Arduino projects that need to keep data even when the Arduino resets or when the power is removed. It is especially useful to remember the last state of a variable or to remember how many times an appliance was activated. For example, imagine the following scenario. You are controlling a lamp with your Arduino and the lamp is on. The Arduino suddenly loses power. When the power is back, the lamp stays off. It doesn't keep the last change. But you don't want this to happen. You want the Arduino to remember what was happening before losing power and return to the last state. To solve this problem, you can save the lamp state in the EEPROM and add a condition to your sketch to initially check whether the state of the lamp corresponds to the state previously saved in the EEPROM. See, here in the graph we have shown the LED is off. We have pressed the push button to turn the LED on. LED is on. Now Arduino loses power. When the Arduino is powered on again, the LED is off. It does not retain the previous state. But what we want is the LED is powered off. We press the push button, the LED is glowing. Arduino loses power and gets the power back, and the LED automatically turns on or restarts. So this is an application of an EEPROM. We will see it later. Now we will speak about internal EEPROM. Adding EEPROM capability to an Arduino project is quite straightforward. Many Arduino boards already have some internal EEPROM you can use in your program. The exact amount of EEPROM depends on the Arduino model. Arduino Atmega 2560 or Arduino Mega, the EEPROM capacity is 4096 bytes, that is 4 kilobytes. In Atmega 328, that is Arduino Uno, Mini and some Nanos, there are 1024 bytes, that means 1 kilobyte. And in Atmega 168, some old Nanos, they have 512 bytes. Now if we speak about external EEPROM, if we need more EEPROM capacity than what is in the internal EEPROM of an Arduino, we can add an external EEPROM. EEPROMs typically operate at a bit level, often using serial data, which is transmitted one bit at a time. This led to the development of many I2C based EEPROM devices. Using I2C EEPROMs with an Arduino is straightforward, as Arduino has built-in support for I2C and libraries to use them. Many I2C based EEPROMs can be configured with unique addresses, allowing you to use multiple EEPROM devices in the same circuit. Another advantage of some I2C based EEPROMs is that they often have a higher write cycles tolerance than the Arduino's internal EEPROM, which is limited to around 100,000 write cycles. This is a picture of an external EEPROM module. In our next video, we will explain about this module and we will see how this module works with Arduino. But in today's video, we will only limit to the internal EEPROM of Arduino. Now let us see how we can represent an EEPROM memory. If we consider the EEPROM memory allocation in a Arduino, there are 1024 bytes. So we can assume each byte as a cell. 1 byte equal to 1 cell. So there are 1024 cells, and if we number the cells from 0, it will be from number 0 to 1023 cells in the EEPROM, and we can consider each cell to store 1 byte. So as 1 byte equal to 8 bits, so each cell can hold 8 bits. That means each cell can hold 8 zeros to 8 ones in binary. That means in decimal it can hold 0 to 255 in decimal. We are talking about each cell, what each cell can hold. There are methods that we can use to store more than 1 byte data. We will also see that in later applications. So in simple words, this is the EEPROM memory allocation. Now each EEPROM cell, as we said, can hold 1 byte or 8 bits, each bit either 0 or 1, allowing Arduino Uno to store 1024 separate pieces of data. You can erase or rewrite these cells as needed. A byte can store numerical data from 0 to 255 in decimal. To store a number in EEPROM, you provide the cell's address and the value you want to store. To read from the EEPROM, you send the address and get back the stored value. According to the datasheet for the Atmega 328, EEPROM cells can withstand about 100,000 read-write cycles, and writing data to a cell takes around 3.3 milliseconds. Although this might sound fast, it's actually slower than other types of memory. Additionally, by default, each EEPROM cell has a value of 255 before we edit the value of the cell. So when the memory is new, each cell contains the binary value 11111111. Now we will look into the process of accessing the EEPROM in Arduino. So here we have written a sketch for writing values in the Arduino EEPROM. In this program, we will write 10 random values in the first 10 address locations of the Arduino EEPROM. This is very straightforward and simple program. First, we have to include the EEPROM.h library. This library is needed to access the EEPROM in the Arduino. Now we have defined a variable called num. This will store the random number, and we have written the entire sketch in the setup section so that it does not loop. First, we have initiated the serial with serial begin. Then here we have added a loop so that the program does not execute until we open the serial monitor. After we open the serial monitor, this code will execute. So here is the for loop. It will repeat 10 times, and we have generated a random number between 0 and 255. Then we have written the random number in the memory locations which will increase one by one from 0 to 9. Then we have displayed the result in the serial monitor. Here we have used the serial monitor to display the memory address and then the random number which is written in the serial monitor, and we have added a small delay after each write. This is the code, very simple. We have not put any code in the loop section. Here in our project we are using an Arduino Nano. So let's connect the Arduino Nano with the computer and see what happens after we execute the code. Now we will connect the Arduino with the computer. And we will upload the EEPROM.write code. So first, let us upload the sketch into the Arduino. Uploading done. Now it won't execute until we open the serial monitor, as we have said while explaining the code. So here we are opening the serial monitor. You can see in the address 0, the value stored is 232, then 1 and 19, then 2, 158, and in the address 9 it is 109. So 10 random values are stored in the addresses 0 to 9. Now how do we know that this is stored in the Arduino? After writing data in the Arduino EEPROM, now we have to read the data from the EEPROM. So here is the small code that will help us to read the variables that we have stored in the EEPROM addresses. So we have included the EEPROM.h library, then the same variable, that's num, and in the setup section we have started the serial, then a loop to keep the program stopped until the serial monitor is opened again, and then in a for loop we have read the values that we have stored. So one by one these values will be read and this will be displayed in the serial monitor. Very simple program, but we can see how we can write and read the data into the EEPROM. Now our Arduino Nano is already connected in the computer. We will upload this sketch and see what happens in the serial monitor. So compiling done, uploading, and done uploading. Now this code also will not execute until we open the serial monitor. So here we open the serial monitor. See, one by one the values are retrieving from the EEPROM memory. All these values were stored in the EEPROM. So in this way, very simply, we can read and write to the EEPROM. Now situation may happen that we need to clear the EEPROM, all the values. We do not know which value is stored at which address. We need to clear the EEPROM. For that we have to run a new sketch to clear the EEPROM. So this program will be used to clear the EEPROM. Here we have set the pin mode 13 as LED, which will indicate the end of the process, and we will run a loop until the end of the EEPROM or the length of the EEPROM, and we will write 0 in all the addresses. And once it's complete, we will write a high to digital pin 13. So we are uploading this sketch. Done uploading, and you can see in the Arduino the pin number 13, the built-in LED is glowing. So in this way we can clear the memory of the Arduino. Now if we run the read program again. We are uploading the read program again. You see all the addresses have zeros stored in it. So in this way we can clear the EEPROM of an Arduino. Very simple process and we can do it very easily. Now we will have a look in an application program of EEPROM. The example that we have given in the theory section, that we want to run an LED and when the power is gone then the LED retains its status. We will see that application here. So we have written the code. It is a simple code to turn on and off an LED. Here we have taken the EEPROM.h library, then a button pin. This is digital pin 2. Here we will connect the push button. LED pin, this pin we will connect the LED, and an address variable which will store the address of the memory location. We will use only the location 0 memory. Now we have taken some variables, that is button state, which stores the state of the button, whether the button is pressed or not. Then the LED state, whether the LED is glowing or not, and one byte type variable, that is value, which will store the value to be written or read in the EEPROM. So in the setup section we have declared the pin mode of the LED, the pin mode of the LED pin as output, the button pin as input, and we have read initially the value from the EEPROM to get the last status of the LED. As per the value that we have read, we will initiate the LED pin as the value. If it was high in the last state, the LED pin will glow, and if it is low in the last state, the LED pin will not glow. And we will state the value of the LED variable with the value of the value variable. Now here is our program code. We will simply check the button state. When the button state is high, we will turn on the LED in one press, and we will turn off the LED in one press. When the LED is turned on, we will set the EEPROM value as high, and when the LED is turned off, we will set the EEPROM value as low to retain the status. So very simple code. I have given all this code for download in the description section. So you can download it from there and use the code, and you can also change the code as per your need. There is no restriction on it. So now we will upload this sketch in the Arduino Nano and see the application. In this application we will see how the Arduino EEPROM retains the value of this LED. So for this we are connecting the Arduino with the computer. So the Arduino is powered up. Now we will upload the sketch into the Arduino. Now we click on the upload button. The code is uploaded. Now here we will see that this button toggles the LED. Now let's see what happens. This is now in turned off state. We click the button, it turned on, and we disconnected the power from the Arduino. Now once again when we reconnect the power, you see the LED automatically turns on. So the EEPROM has stored the status of this LED. Now we will turn it off and we will remove the power from the Arduino. Then we will reconnect the power, and you see this time the LED does not turn on. You can see the Arduino retains the status of the LED. So this way we can use any accessory with the Arduino. We can retain their status or we can retain their value and resume it when we restart the Arduino or we reset the Arduino. Now one question may arise in your mind, that is EEPROM limited to only decimal values up to 255, or we can store more than that? So here I will show how we can store fraction into the EEPROM. For that, instead of read and write, we have two more functions, that is get and put. The put is a substitute of the write EEPROM.write, and the get is a substitute of EEPROM.read. So we will show an example of that. First we are showing EEPROM.put. So we have included the EEPROM.h. Next we have started the serial, and we have taken two variables, f1 and f2. f1 value is this and f2 value is this, and we have taken a variable to identify the address of the EEPROM. Now first we will use EEPROM.put in the address this value of f1. Now since the value of a float is more than 1 byte, we are increasing the address of the EEPROM to the size of the float variable. So initially the address of this variable was 0, but when we are doing this, it will be 0 plus the size of float. So we are putting the f2 variable in the EE address this time. Now then serial.print return float data type. The process is complete, and in the loop section we have not written any code. So first we will upload this sketch into the Arduino. Uploading is done. Now we will open a program to retrieve the variables. So in this program we have also defined two variables, f1 and f2, and the address. Now we will read float from the EEPROM. So initially we are reading the f1 variable from the address, that is location 0. Then we are printing the result, and then we are increasing the address to 0 plus size of float, and then we are retrieving the variable f2 from there. Then we are printing the variable f2 from the memory location. So let's upload this code. Uploading done. Now we will open the serial monitor. Read float from EEPROM, the first float value and the second float value. So this way we can store more than 1 byte variables into Arduino EEPROM. One more function of the EEPROM object is there, that is EEPROM.update. When we are writing something, we are decreasing the life of the EEPROM, but the update function does what? It first checks whether the same value exists in that memory address. If the same value exists, then it does not write the value again. So this way it saves the write cycle into the EEPROM overall life. The code is similar to EEPROM.write function. So we are not taking much time to explain that. You can easily replace the .write function with .update function, and this will do the same function. So with this we are concluding how we can use the EEPROM of Arduino. If you have any query or question, please feel free to ask me in the comments. I will definitely try to answer your query. In our next tutorial, I will show how we can use external EEPROM with Arduino. If you like the video, please click the like button and do subscribe my channel. We will meet again in a new video. Till then, bye bye, take care, thank you for watching.